Your whole goal in life is to get the highest lean mass at the lowest fat mass. Basically, you want to be a bodybuilder. So if I just snap my fingers and you're a bodybuilder, you have very little body fat, tons of muscle. This is the very best metabolic situation of all because you can dispose of all kinds of energy in your muscles. When you eat a ton of fat, your fat cells all just hoover it out of your bloodstream on the first pass. Basically, their fat cells are so insulin sensitive, it just sucks all the fat right out of their bloodstream the first pass. All of your type 2 diabetics are the opposite of bodybuilders. They're usually sarcopenic, very little muscle, hardly ever exercise, no place to dispose of anything in their muscles. And then their fat cells are all just maxed out. If you look at the average diameter of adipocytes in type 2 diabetics, it's double that of normal non-diabetic population. That is why they can't dispose of any calories because they have no place to put it. Carbs and fats are there to support your stored energy, fat mass, and protein's there to support your lean mass. So the PE diet makes perfect sense for basically anybody, anytime, anywhere. And it's all about prioritizing lean mass over fat mass.
More often than not in today's health world, when it comes to weight loss, the focus is either on lowering calories or lowering the carbs when it comes to the dietary piece. Your approach and framework is to come at it from increasing the protein. Talk about why that is.
Gotcha. Okay. So I think a lot of people are unaware of protein leverage, which is a fairly recent discovery. Well, in the past decade or so. Protein leverage was discovered by Professors Raubenheimer and Simpson, these researchers down in Australia, and they have been looking at all sorts of animal species, and they realized that most animals will basically eat and eat and eat until they get enough protein, and only then will they stop eating. And a lot of animals will overeat carbs and fats just to achieve adequate amount of protein. So this is known as protein leverage, and it's kind of weird because for the longest time, researchers didn't really look at protein as being a factor with the obesity epidemic. And that's because there were all these changes to carbs and fats. But all over the planet, different species, different groups of humans, they were all eating about the same amount of protein. So nobody really paid any attention to it. Protein's also kind of the smallest of the three macronutrients, maybe 14% of your average human's diet. And so they're like, well, protein's so small, doesn't really matter. It's precisely because protein's so small that it's absolutely critical and exerts the most leverage over how much people eat on an ad lib diet where they're basically eating to satiety. So protein leverage is this massive factor that nobody's aware of. And that's kind of why I wrote this book, The PE Diet. It's basically to open people's eyes to the fact that you're going to eat until you achieve protein adequacy. And so the protein percent of your food is a huge, big deal. Basically, the higher the protein percentage of any animal's food, the less calories they're going to eat when they're just eating to satiety. It's kind of a big deal. So basically, humans have sort of two needs in their diet. You have to eat enough calories to be alive, and that could either be carbs or fats interchangeably. These are just hydrocarbons, which are fats, and carbohydrates, which are carbs, are just chains of carbons. They're very similar. They're carbons with hydrogen and oxygen and high energy bonds, and your mitochondria break them down and burn them pretty much exactly the same. You're just splitting apart the bonds in the presence of oxygen, and you're getting a little bit of energy and then exhaling the carbons from those carbon chains as carbon dioxide. And that's how you get all of your energy. It's carbs or fats fairly interchangeably. But protein and minerals and nutrients are a little bit different. You have to achieve protein adequacy in your body's not using that really for energy. Your body is mostly using protein structurally. It's the main component of your entire physical body and all of your enzymes, all of your hormones. And so your body's structure and function is mostly protein. And so you're eating protein for this structural component and nutrition, and then you're eating carbs or fats interchangeably for energy. And balancing this ratio is something that all animals do. You can basically take any animal and put it in an environment and give it a pure protein source and then a pure energy source, carbs or fats, and that animal will just eat a little bit of both automatically and kind of automatically find a protein percentage that's going to be optimal for its function. The problem is when you lock an animal up and totally control its food supply and then give it a food where the protein has been diluted with carbs and fats, basically a low protein percentage, that animal is forced to overeat carb and fat calories in order to get enough protein to not be hungry. And that's pretty much what we've done to the entire human food supply. And that's why, wild animals are never obese, but animals under human care are most of the time obese or overweight because they are given foods that are protein diluted because they're cheaper if you dump a bunch of carbs and fats in there. And that's this protein leverage thing is really, really huge in the obesity epidemic, and most people just aren't aware of it. And this is just kind of a way to get people to realize, oh, hey, the protein percentage of my diet is possibly the single largest factor when it comes to how many calories I'm going to eat.
And when it comes specifically to the physiology of continuing to eat till you get to whatever that threshold of protein is, what is it specifically about protein that switches that in the body and we're allowed to push the food aside and feel satiated? Is it the amino acids? Is it something, micronutrients that come alongside the protein? What is it specifically?
It's a number of things. Well, first of all, it is the amino acids themselves. So these amino acids appear in the bloodstream after you eat protein, and your brain actually detects those, and they actually contribute to satiety significantly. Also, your gastrointestinal tract will emit all of these incretin hormones, the GLP-1 incretins that we're familiar now with all these GLP-1 drugs like Ozempic, and these are basically mimicking this hormone that's released in the gastrointestinal tract when you eat things like protein and fiber and things that have a large weight and volume. So eating protein stimulates these satiety hormones in your bloodstream that your brain detects. They also release amino acids into your bloodstream, which the brain can detect directly. And so there's a number of mechanisms, but the end result of all of it is you get a higher satiety per calorie when it comes to protein versus carbs or fats. That's why protein is, without question, the most satiating macronutrient. And pretty much everybody knows that and has known that for a long time. But yeah, the mechanisms are mostly incretin hormones and then direct sensing of amino acids in your brain.
All right. So when it comes to getting to this certain threshold of protein, upping our protein for most people, given as a society of how we're eating these days, what is the goal? How do we get to that threshold of where we want to be?
So the biggest factor is really just protein percentage. So everyone's eating enough protein. I'm eating enough protein. You're eating enough protein. Everyone's eating enough protein. The problem is how many excess carb and fat calories did you have to eat in order to get that protein? If you're eating super high protein foods, you're going to achieve this protein at a much lower caloric intake. But if you're eating some cheap protein dilute garbage, basically all of your junk food is just horrifically low in protein. And you might have to overeat thousands of calories to get enough protein. So you don't really have to worry about, did I eat enough protein? Am I eating enough protein? You just choose foods with a higher protein percentage, and you'll automatically get the right amount of protein and calories as you're eating to satiety. And that's pretty much how every animal has worked since forever. So it's really protein percentage of the foods you're eating that you have to focus on. If they're too low, you're just going to overeat. It's unavoidable.
How do we pick these foods that are higher in protein?
With whole foods, you really almost don't have to worry about it. So if you look at worldwide hunter-gatherer macronutrients, they're maybe 30% protein by calories. And that's because, you just go out and kill an animal and eat the whole thing. And then you're scrounging around for whatever carbs and fats you can find. If you're living on the equator, you're going to eat way more carbs just because there's a lot more plant energy available. If you're living closer to the Arctic, you're going to be eating a lot more fat because all you've got is animal fat and there's not as much plant energy. So the carb and fat spectrum could change radically, but the amount of protein you're eating as a hunter-gatherer is pretty much 30%. And it's just because the foods in your environment are very high in protein, very high in fiber, and a little bit low in carbs and fats. Like, if we just dump you off on the globe at a random time of year, random location. All you've got is a loincloth and a spear. You're going to find out really fast that all the animals you're hunting are themselves fairly lean and starving for energy and trying to get enough energy. And so you're going to get tons of protein from these lean wild game animals, but not a lot of fat. You're going to go out of your way to get more fat by eating bone marrow and organs and things like that. Same thing with plants. You might find some tubers or some fruit, but it's going to be fairly tough and shriveled up and fibrous and very low yield on the carbohydrate side because it's not like your grocery store fruit that's ginormous and been specifically bred to maximize the energy yield. So as a hunter gatherer, you're getting lots of protein, lots of fiber, but you're always looking for some extra carbs or fats. That's animal fat, highly prized, honey, fruit. You're going to eat a lot of that whenever you can find it. So if you just go outside and eat stuff, you're pretty much fine. You're also, when you're eating whole natural foods, you're eating foods in a cellular form, which means you're getting this nice combination of protein from the organelles and fats from the cell membranes. And you're just never going to get into a ton of trouble when it comes to any whole natural foods. The problem is when we refine carbs and fats, we basically suck all the energy calories out of things like corn and make corn oil and corn syrup. Or you've got soybeans, which are awesome. They're 35, 40% protein. But then we make soybean oil out of them. And that's basically just zero protein whatsoever. So the real problem is refinement of carbs and fats. And then all of our processed foods, which are just basically made out of refined carbs and refined fats, sugar and flour and oil, which makes it way tastier, way more hedonic, but very protein dilute. So you're simultaneously forced to overeat these foods in order to get enough protein and not be hungry. And you're also driven to overeat them because they're so tasty and delicious. And your hunter-gatherer brain lights up like a slot machine every time you get a donut or something like that. So whole foods, you don't really have to worry about it. Like, if you're just eating real, actual whole foods as a hunter-gatherer, nobody really has to sweat these details. You can survive as a hunter-gatherer on lower protein diets, and you'll pretty much be fine because you're going to automatically be eating more fiber and more weight and volume, and you're not going to overeat. You can also survive on higher protein diets, and that'll be fine too. The carb and fat mixture doesn't seem to matter really at all. And so whole foods, hunter-gatherers, no problem. Don't have to worry about it. All of our processed and packaged foods, you do have to worry about. And almost exclusively, that's due to the refinement of carbs or fats or both, usually both.
If you're enjoying this episode, take a second and let me know by clicking like and subscribe below. Thank you so much. And now back to the show. As you talk about hunter-gatherers, it gets me thinking about modern society and our access to being able to go to the grocery store. And if we wanted to, we could pick fatty cuts of meat day in, day out, push aside, the white meat and just get the dark meat when it comes to chicken with the skin on. The difference these days is it's really easy, given the modern food environment, to pick the fattier cuts of meat. So how, when you're navigating a grocery store, do you look at that? Because before, we're typically going to eat the whole animal and it's going to naturally, balance out, versus today where you can go get ribeyes and eat those for dinner every night.
So the closer you can get to, just going out and killing an animal and eating it, the better. So if I just find some sort of wild animal and kill it and eat it, very high protein percent, very little dilution with that. But when I have my factory farmed, grain-fed beef, that's just heavily marbled and way fatter than any cow should ever be, possibly even metabolically unhealthy or diabetic animal. And then I'm intentionally picking the very fattest part of that, or maybe even concentrating in the fat more. Like, so for example, if you killed a wild boar and ate it, you're getting an absurdly high protein percentage. But when we force-fed pigs with a bunch of just, soybean oil and all of these cast-off high-energy products that are basically just carbs and fats, you get a a lot more fat content in this animal. And then if I intentionally just take the pork belly, which is the highest fat part, and I slice it up into bacon, now I'm eating the fattest part of the fattest animal that's been artificially over fattened, and you're really not getting a great protein to energy ratio. To make things worse, I might get a processed meat like bologna or hot dogs, and the protein percent might be horrible. You can find hot dogs where protein percentage, 20%, 15%, a lot of sausage, hot dogs. They will dump in way more fat because it's a lot cheaper than protein to produce. And it gives you a product that is actually pretty terrible on protein percentage, way too much fat calories. And that's really just economics. So if you look at the price of every single food in the grocery store, it is pretty much just linear with protein percentage, full stop. Carbs and fats are so cheap, they're almost free. But the leaner something is, the more expensive it's going to be. So all of your super lean proteins, like your skinless chicken breast and your filet mignon and your shrimp and your wild caught seafood, all very, very expensive. Fattier things are actually way cheaper. Your farmed Atlantic salmon, might have triple the fat content, a much worse protein energy ratio, but it's dirt cheap. Your wild caught salmon, you can just look at farm salmon and see the marbling and all the white fat in there. And check out the macros. I mean, you're literally going to get double or triple the fat grams per serving. And then your wild caught salmon, way more expensive, a lot less marbling. You can just look at it visually. If you look at any kind of grass-fed beef, versus factory farm, if you look at any kind of wild caught versus farmed on pretty much anything, you're just going to get more and more fat. The way you can combat that is try to purchase animals that were properly raised, things that were pastured and grass-fed. And you can also, if you aren't able to control the quality, aim for something leaner because it's less likely to be problematic. So if I know that I'm eating out and I'm just getting some, factory farm chicken, if I choose a leaner cut like a chicken breast, I don't really have to worry about the protein energy ratio as much because I'm just picking a leaner portion. You know what I mean? So if you aim for something leaner when you don't have control over the animal quality, then you're probably going to be better off. You're probably going to be safer that way.
And to this point, we've been focusing on macronutrients and highlighting protein. And I can see how, from a micronutrient perspective, wild salmon, using that example, would be loaded with nutrition on a micronutrient scale. But where this gets tricky is if we start eating more chicken breasts and pulling the skin off our chicken, do you ever worry that on a micronutrient scale, we're going to be depleting those nutrients over time versus eating, dark meat and fattier cuts?
Not really, because interestingly enough, you can draw a graph of every single micronutrient, vitamin and mineral, versus protein, and it's just a straight line. All of your micronutrients track with protein extremely well, and they don't really track with fat and with carbohydrates. So if you are chasing the protein, you're actually going to get the highest yield of micronutrients as well, which makes a lot of sense because carbs and fats, when plants manufacture carbs and fats, they just use sunlight, energy, carbon dioxide in the atmosphere, water. That's all you need. You perform photosynthesis, you can make just a crap ton of carbs and fats. Protein is different. Your plant has to suck nitrogen out of the soil in mineral form, and it's also sucking out the other dozen or two micronutrients that form the minerals that are in the entire food supply. Basically, all food for all animals is made by plants, and they're doing photosynthesis just using carbon dioxide and sunlight, but they're also sucking these minerals out of the soil, nitrogen for protein, and then all of your other like sulfur for essential amino acids and all of your other minerals that are required for human and or animal and plant life. And these minerals, because they're associated with nitrogen, which is the basis of protein, amino acids, there's a very tight association between all of your micronutrients and protein itself. So you kind of don't have to worry about that. If you're chasing protein, you're going to get the highest micros most of the time anyway. So that's really not, I mean, the only time I would be worried is if someone was on trying to eat just a zero fat diet. You might have a problem with some of the fat soluble vitamins. But for the most part, you don't have to worry about it if you're targeting protein.
Okay. I guess when we start talking about upping the protein, I start thinking about chicken breasts and steamed broccoli and protein shakes and bodybuilder type foods. And I'm picturing, diversity coming down and narrowing on that kind of diet. And that's where the micronutrient piece comes in. But you're saying as long as I'm assuming you'd want to eat quite a diversity within that realm still, and you'd get the micronutrients you need.
Yeah, I don't think I wouldn't recommend a mono diet of just exclusively chicken breast. You would definitely want a little bit more diversity in there. So I absolutely hear what you're saying. And I do think that's legitimate. Um, but on the other hand, you could just live off of red meat. There are tons of people doing that. So do you have to specifically eat a certain amount of fat in order to get all those micronutrients? Yeah, it can't be zero, but it could actually be fairly low and you'd survive. You will need a certain amount of energy calories, but you can get those from carbs or fats pretty much interchangeably. And the micros are really tracking with that protein way more than the carbs or the fat.
And how do you look at distribution throughout a day with protein? Getting it, a bolus in the morning, spreading it out through the day, making sure, that amino acid pool is available for the body as needed. Is that really a concern when you're eating a diet like we're talking about?
It is a concern, and that's because your body doesn't really have storage for protein. So you can go, weeks without eating any carbs or fats. All of us have, about 2 months worth of calories stored on our bodies. And it's not a big deal well, first of all, carbohydrate is completely optional and you can live your whole life without eating any carbs. And then the amount of essential fatty acids you need every day is just a couple of grams. It's shockingly small. There's really only two essential fatty acids you need. You only need a couple grams of those. And you can live on very little fat, very little carbs, and then, like I said, you've got a ton of energy on your body. What you don't have is protein. So every day there's about a turnover of about 300 grams of protein in your body. You're recycling as many of those amino acids as you can. So you really only have to eat about 50 grams of protein a day to be alive. Most people could live on 50 grams of protein a day. You're not going to live really well. There's going to be a lot of triage going on. So you might not grow skin and hair and nails at the same rate that you would otherwise would. And your body's going to be hanging on to a lot of this stuff. So you're not going to be building any new muscle or anything like that. But you could live on 50 grams of protein a day. The problem is when you don't eat any protein, you immediately start breaking down lean mass, muscle tissue. So this is especially problematic for older people who are on a downhill slide for muscle mass anyway. Half the planet has sarcopenia to begin with. As you get older, you have more catabolism, which is breakdown of lean mass. It's harder to put on lean mass. You get anabolic resistance. So I'm very worried about people losing lean mass if they're going extended periods of time without protein. Now, could you survive by just eating one giant protein meal a day? Absolutely, that would work. That is possible. It's not exactly optimal. I think optimal would be, at least two large protein containing meals, maybe bookending an 8-hour window. So while you could get by with one protein meal a day, it's probably better to have two and spread them out over a eating window, just so you have more amino acids available to prevent muscle protein breakdown if you've gone, 24 hours without protein, or possibly to enable muscle protein synthesis if you're doing some resistance training and trying to build muscle, which all of us should be doing all the time, right? The whole goal is to get more muscle, less fat. And so you want to eat protein at least a couple times a day, and that'll support your training and building muscle and lean mass, and also prevent muscle breakdown. So I don't think people have to eat, 6 times a day like a bodybuilder. Although as you get leaner and leaner and leaner, you have more and more lean mass losses when you're under eating calories. So eating protein more frequently becomes important. If you're a bodybuilder doing stage prep, you really do want those, 6 Tupperwares a day with little chicken breast and shrimp in there, because your calorie availability is so low and your body's just going to start chopping up the furniture for kindling, so to speak. You're going to be breaking down muscle if you're not replenishing it. So, yeah, I would say for most people, at least 2 large protein boluses, bookending an 8-hour window as kind of a minimum. And then possibly, a little bit more protein here and there. But I think that would work for a lot of people.
You mentioned muscle protein synthesis, and that was part of what brought up that last question. Thinking of Don Layman's work, who's the previous guest of the show, and having that bolus, I think for him, it's 30 grams that first meal of the day. How do you think about that, setting yourself up and having, you mentioned an 8-hour eating window. So a couple different pieces here. How do you think about having, say, 30 grams plus as first meal of the day, and then narrowing an eating window for you?
Gotcha. Okay. So intermittent fasting, I do think, is lightly beneficial. It can be taken too far. If you're really trying to eat just one meal a day or going days without eating, you're going to have a little bit more problems with lean mass loss. You might also get excessively hungry. And when you refeed, you're going to be more likely to just eat a whole jar of peanut butter or a dozen Krispy Kremes. So I don't like leveraging fasting too much. I don't like shrinking it down to one meal a day. I don't like multi-day fasts. I don't usually recommend people go that long without eating. But on the other hand, if you do have a little bit of a compressed eating window, it has a lot of benefits. It helps people get more in touch with hunger and fullness. You get a little more used to just being fat adapted and living off of stored body fat. You can tell when you're actually hungry versus you're just not snacking every few hours. You know what I mean? So I think it's helpful to get people in touch with a bit of hunger and fullness. I think it's helpful to cut down on snacking and just have larger bolus meals. And there is a ton of research now on intermittent fasting showing that a light intermittent fast is actually slightly beneficial. It doesn't really scale. It's not like if a little bit of intermittent fasting is good, a ton of it's really good. And then if you just don't eat for a year, that's the best. So it doesn't really scale. It's on a U-shaped curve. You want maybe a light intermittent fast just to get in touch with hunger and fullness, bolusing your meals, cutting down on snacking, getting more fat adapted. These are all beneficial, I think. And then in terms of like how much protein you eat and at which meals, people are failing at breakfast in America. It's just a nightmare disaster. Most people are eating enough protein for dinner. They're eating not enough protein for lunch, but it's not as terrible. Breakfast is just atrocious. And so we have all these studies showing that if you eat more protein for your first meal, it doesn't matter what time of day it is. That's just breaking your fast. For your basically first meal, if you can drag that up to 30 grams of protein, you will literally eat fewer calories automatically and spontaneously later in the day. There's absolute research on this where increasing your protein intake for your first meal is hugely beneficial when it comes to just eating less automatically, having higher satiety per calorie, and just losing fat. So most people are totally unaware of protein leverage. They're totally unaware of how much protein is in any foods. They're totally aware of how much protein they're eating. And when I do these 24-hour diet recalls with people in the clinic, and I'm like, okay, so what do you eat for breakfast? They're like, oh, well, I have tons of protein. I always eat protein. I have an egg every morning. What they don't realize is an egg is 6 grams of protein. That is a nice start, but it's basically like they're horribly under proteining their breakfasts, basically. And so the first thing you want to do is protein awareness. Just be aware of like how much protein is in everything I just ate. How many grams did I eat for breakfast? Oh, wow, it's shockingly low. It's like, no wonder I'm hungry 2 hours later and I'm eating muffins and bagels and donuts and all these things. So if you can be aware of protein, count your protein grams, focus on that first meal, 30 grams would be nice. Ideally 30 to 50 grams for most people for those 2 big protein meals, first and last in your 8-hour window, would be great. And you're only going to do that if you're really going out of your way to eat high protein percentage food. So yeah, I'm a huge fan of Don Layman. He's amazing. Love that guy. Anything he says is accurate. And he's right. You should absolutely be trying to get at least 30 grams of protein in your first meal. And that is a big deal.
Well, let's talk about what you eat in a day. This will give us a good idea of what eating for high protein looks like. So talk about when you break your fast and what you'll eat throughout the day.
Absolutely. So I typically eat in an 8-hour window ish. I'm not very militant about it because it's not that big a deal. And I'd rather just have some flexibility and not sweat these details. It's, better psychologically, and it's really not that helpful to be super rigid about it. So I'm roughly eating in an 8-hour window. It is better metabolically, if everything else is equal, to have that window earlier in the day. But I don't do that just because it's not convenient for me. So I basically skip breakfast and I eat lunch and dinner in an 8-hour window. And so my first meal, if I'm at home, I might have Greek yogurt. Love Greek yogurt. I love any kind of low fat dairy. So I eat a ton of basically non-fat, artificially sweetened Greek yogurt. And I might put some blueberries on there. I might have make some steel cut oats to go with it. I might have some other carbohydrate source like, Ezekiel bread, steel cut oats, blueberries, some other kind of fruit. But I'm getting a ton of protein from the Greek yogurt. I might also make an omelet. I will use low fat cheese. I will sometimes use 2 eggs and 2 egg whites, just up the protein. Sometimes I'll put something else in the omelet, like some smoked salmon or something like that. If I'm at work, I will frequently just take leftovers from the night before and eat that for my first meal. And that's usually some sort of lean meat, some sort of fibrous vegetable. And then if I'm eating a fattier meat, I might not eat a lot of carbohydrate with it. But if I'm eating something very lean, I might throw in more carbs, like a potato cooked in the air fryer without added fat, or some wild rice, brown rice, some sort of whole grain with no added fat. So it's pretty much a protein, either something lean and then more carbs like a potato or a tuber or whole grains without added fat, or it might be a fattier piece of meat and then less carbohydrate. So either way, my protein percent is pretty high. If you know what I'm saying, I'm either eating fattier meat and no carbs, or leaner meat and more carbs, and I can make either one work exactly the same. Then for dinner, it's the same template. I'm basically eating either lean meat and a carb that's cellular and high satiety per calorie, high fiber, high water, very low in fat, and that might be either any kind of vegetables, any kind of whole grain without added fat. And then again, if the protein I'm eating is a lot fattier, then I might not eat any carbohydrate with that, or a lot less. So that's how I'm kind of managing the protein to energy ratio there. But yeah, that's typical for me. My favorite proteins, I love, grass-fed beef. I always buy just the leanest thing I can. I'll get the 90% lean ground beef, 93%. 95%, whatever they've got. I'm, trying to buy grass-fed and pastured and that sort of thing whenever I can. Love eggs. Love low-fat fermented dairy, such as low-fat Greek yogurt, cottage cheese, whey powder. Just eating the hell out of fish and seafood. Anything out of the ocean. Always prefer wild caught to farm. So wild caught salmon and any kind of fish or shellfish. So in the plant world, probably my favorite is legumes. I do eat a lot of soybeans, edamame. I eat lentils. I eat black beans. My favorite plant food is a legume because it just has the highest protein percent, plus a ton of fiber and very high satiety per calorie. And yeah, so that's the diet. It's like lean proteins, grass-fed beef, pastured eggs, wild caught fish and seafood, low fat dairy, whole grains without added fat, some tubers that are usually cooked in an air fryer without added fat as well. Any kind of vegetables, any kind of fruit. And it's basically 8-hour window, big protein balls at the beginning and the end, maybe a couple snacks in the middle, depending on how active I am, how many calories I need to that I'm burning that I need to eat and that kind of thing.
And given the importance of protein that we're stressing here, how do you feel about somebody approaching this framework from a plant-only perspective? Do you see a lot of people do that successfully?
Yes. Okay. So it's totally possible. You can absolutely just be ripped and jacked and very successful on a plant only diet. However, you have to eat a ton of protein, mostly legumes. So your best plant protein source by a mile is legumes, soybeans, chickpeas, lentils, any form of concentrated legume protein like tofu, um, or any other sort of concentrated plant protein like wheat gluten or textured vegetable protein and all these other protein concentrates. And so I have vegan bodybuilders who are just crushing it. They're totally ripped and jacked. They could probably kill both of us with their bare hands. They are not. They do have to intentionally eat tons of protein concentrates and focus on protein, and protein has to be the focus of every meal. They're frequently using soy powders and other protein supplements. They're usually supplementing a few other crucial things like B12, like zinc, like iron. But if you're smart and doing some supplementing and chasing the protein, you could absolutely make plant-based work. I do not think that's optimal for anyone. I'm just saying that it's possible. It is absolutely possible. It's not optimal. But again, legumes are really going to be your friends in the plant world.
And where it gets a little bit more nuanced when it's plant only is amino acids. And I know Dr. Gabrielle Lyon, you've been on her podcast before, and she's a big advocate for more protein. And one of her messages is the fact that we're talking about protein as this umbrella term, and we're not really looking at these 20 amino acids so much, which can have a lot of diversity under that umbrella of protein. And again, where this can become more important is when we're talking about plants and incomplete protein sources, different amino acids, and trying to make sure you're getting all the essentials in enough, not just to survive, but thrive.
Right.
So talk about how you think about amino acids, because it's such an important piece of this conversation when it comes to protein.
Absolutely. Okay. So everything that's protein is broken down into the same 20 amino acids. It doesn't matter where it came from. You get the same 20 amino acids. The problem is the percentages of all those amino acids could be different in animal protein versus plant protein. Plant protein, it gives you all the proteins you need to make a plant. Animal protein gives you all the proteins you need to make an animal. You get a better spectrum of aminos for animals from animal protein. Leucine, for example, the leucine is this trigger for muscle protein synthesis, and your gold standard proteins like egg and whey might be 12% leucine, and then your soy or something might be 6% leucine. So you might have literally half the critical amino acids in some of these proteins, which is why you hear that vegans have to combine complementary proteins like rice and beans together in order to get a better spectrum of aminos. That's absolutely true. You can overcome that just by eating more. So we do have studies where they compare plant proteins to animal proteins. And if you just eat more of the plant protein, you're basically going to get by. You might have to eat, in some cases, up to twice as much. But for the most part, if you're just looking on average, you'd have to eat about 30% more protein from plants in order to be covered and to be basically doing just as well as you would from animal protein. So if somebody's eating tons of protein, plenty of protein, a really high protein percent foods, really good protein adequacy, I'm not that worried about it because I know they're going to make it. I'm super worried about people who are flying their protein plane just a couple feet off the ground. And that's like your elderly female who's eating, maybe upper 40s grams of protein a day. If I snap my fingers and suddenly all those people were pure vegans and we're just getting that from plant protein instead of animal protein, that would actually be problematic instantaneously. So if you're not eating a ton of protein to begin with, protein quality is a big deal, and animal protein is always better than plant protein. But if you're eating a ton of it and you're eating a fair variety of plant proteins, then it's not that big a deal. In fact, you're basically fine. So your vegan bodybuilder is fine just because they're eating so much protein.
We've touched on different pieces throughout the conversation, but let's talk about the PE diet, which is actually a framework that works with different diets and this whole aspect of carbs and fat. And when you're talking about your diet, you got into the fact that if you're having more carbs, you're going to bring down the fat. If you're going to have a fattier, I think you talked about cut of meat, you're going to bring down the carbs. So the whole energy versus protein balance.
Right. Okay, yeah. So the PE diet is really just looking at the ratio of protein to non-protein energy in your diet, which is carbs and fats. And the idea is to be aware of it. And I'm not prescribing a particular ratio for anyone. I just want you to know where you're at. And then if you're trying to eat less, you just raise it a little bit in a sustainable way. You know what I mean? It could be as simple as just look at every single thing you eat now and pick a leaner protein. You know what I mean? Switch from the fattiest pork bacon you can find to maybe like Canadian bacon or ham or turkey bacon or something a little bit leaner, like chicken sausage or something that you're basically going to automatically eat fewer calories because you have a higher protein percentage and you're going to have higher satiety per calorie, and then you're just going to eat less. So you could look at anything you're eating that has carbs or fats in it and just either lower the carbs, lower the fat, or both. It's really kind of being low carb and low fat at the same time. And then being aware of the fact that you could switch back and forth between carbs or fats. You could be lower in carbs, you could be lower in fat, you could be lower in both. But either one will directionally raise protein percent, which is what you're trying to do. So it's pretty much just target protein, maybe get leaner proteins, maybe get higher fiber, lower carbohydrate options. And it's a kind of low carb and low fat at the same time. That's the very practical take home from the PE diet. It's something that you can do with any dietary pattern, whether you're like, okay, I just want to eat hot dogs and burgers and fries. Okay, sure. But how about air frying your fries in your air fryer without added fat? How about buying extra lean ground beef? How about getting a low carb or whole wheat bun? How about not putting, a ton of mayo on there? And how about just drinking a diet soda instead of your regular Coke or whatever? And so everything you choose, you're trying to get a little bit more protein, a little bit more fiber, and be lower carb and lower fat at the same time. And that's pretty much the secret to the PE diet. The idea is you make these little substitutions that are just a little higher than they were before. Not so high that you hate your diet. You want to eat things that you enjoy and things that are tasty, but you're just trying to tweak these a little bit, shaving off a few grams of carbs and fats here and there to just automatically eat less calories and still enjoy what you're eating. And I think this approach is something that anybody could do anywhere, anytime with any diet by just getting a little bit more protein, a little bit less carbs and fats.
Talk about when people are going lower carb, upping the fat, where they're potentially going wrong there.
Gotcha. Well, first of all, low carb is very effective. I come at this from a low carb direction. I love low carb. I'm a big fan. But if you look at pretty much every single low carb study, protein percent has gone up. And that, in fact, a lot of people think that protein percent increase is a huge factor, possibly the biggest factor powering success of low carb diets. And that's why if you look at studies that match protein and match energy density and match everything else, if you match fiber, protein, energy density, and then just swap out carbs and fats, you're not going to see big differences between low carb or low fat. And this is something we just try to kind of like hand wave away in the low carb world. We don't like to really talk about that, but low fat is pretty much just as effective as low carb if everything else remains exactly the same. Where I think low carb is a bigger win is because people automatically get more protein, whether they're trying to do that intentionally or not. However, you asked me like, where could you go wrong? And I think that's basically in just if you're mono focused on, okay, carbs are bad, but fat's fine. Then a lot of people are like, well, if a little bit of fat is good, more fat is better. And that's how we got, back in the keto craze where everyone was just drinking butter in their coffee and just basically pouring heavy whipping cream on everything. And it was just, a problem. Like, sure, if you cut out carbs, you are just burning exclusively fat. But if the grams of fat you eat every day equals the grams you burn, you're not losing anything. You're just going to stay there forever. So it really does. It's bigger than just avoiding carbs. And so if you treat fat as a free food and you don't worry about other things like protein percentage or energy density or fiber or satiety per calorie, then you are going to potentially lose 20 pounds off the bat and then plateau there forever, which, let's face it, is every single low carber on earth. Everyone instantly loses 20 pounds, loves low carb, stays plateaued forever, or possibly slowly regains because the carb creep is inevitable because humans have an appetite for carb. So as you eat more carbs, but you still think, oh, fat's a free food, you're going to just steadily regain some of that weight, which describes, 99% of low carbers out there. No hate. I like low carb. The PE diet does incorporate low carb approach, but that's just half the story, basically.
I guess when looking at that side of the equation, the energy, we know there are essential fatty acids. Carbohydrates we don't necessarily need. Not necessarily, we don't need them. So if we're going to follow the PE diet and up our protein, focusing on the fat aspect of that energy would be important from that respect.
Oh, correct. Yes, absolutely. So I don't like, super low fat diets. Probably nobody should try to eat less than 30 grams a day. You might start being at risk for insufficient essential fatty acids and gallstones and other problems like that. However, so you really don't want to go to zero on fat. You can go to zero on carbohydrate from a micronutrient perspective. The problem with driving your carbs all the way to zero is it's basically not taking into account the fact that humans have an absolute appetite for carbohydrate, right? We descended from frugivores. We are essentially, humans are supposed to eat fruit and kill other animals. That's basically our diet, meat and fruit. So denying the fact that humans have an appetite for carbohydrate is a mistake because you will have carb creep. And if you're not just eating a certain amount of carbohydrate, you will have this weird carbohydrate hunger that you'll try to satisfy by just eating, a pound of macadamia nuts for 3,000 calories, and you're just going to be struggling. You know what I mean? So the other problem with eating absolutely no carbohydrate whatsoever is you're pretty much having to manufacture all your glucose that you need to be alive from scratch. Now you need, at least, let's say 50, 60, 70 grams of glucose a day just to be alive for your brain and your red blood cells and all these cells that don't have mitochondria and that have to use glucose for energy. And if you're not eating any glucose, you have to manufacture that out of protein. So you have to do more gluconeogenesis, breaking down protein for glucose, which is not very protein sparing, which means you have less protein available. And we've already highlighted the fact that a lot of people aren't eating enough protein to begin with. Then you've got the fact that if you're doing high intensity exercise, as your heart rate and your intensity goes up, you're burning higher and higher and higher percentages of glucose to the point that when you're just sprinting, you're burning 100% glucose at about a gram of glucose a minute. So if I need, 70 grams of glucose just to be alive, and I'm doing a half an hour of, high intensity exercise, and I need another, 50 grams of glucose or so, now I'm really in a hole if I have to manufacture it all from protein. And wouldn't it be a little bit smarter to just go ahead and eat that glucose, simultaneously sparing protein because I've given myself the glucose I need for high intensity energy and just to be alive, and then also satisfying the human appetite for carbohydrate that is a very real thing and is frequently just completely overlooked by people in the low carb world, or they try to overlook it, but it's still there. So my advice is, go ahead and eat, at least 100 grams of carbs a day, maybe even 1 gram per pound of ideal body weight. which is about what I'm eating in carbohydrate, maybe 160 grams or so, with the caveat that you try to eat as much of that in a cellular form as possible. So you get a better spectrum of macros and micros. And with the caveat that you try to eat as much water and fiber and weight and volume with those carbs as possible, because you get a way higher satiety per calorie. So for example, if I'm going to eat 100 grams of carbs from strawberries, so that's 12 cups of strawberries. That's 4 pounds of strawberries. That's a shit ton of strawberries. So I'm going to get way more satiety versus if I'm doing that from sugar, it's like, third of a cup of sugar. And if I drink that in a soda, that's, poof. I have zero satiety per calorie. I will still eat just as much for my next meal as if I hadn't consumed any calories at all. So it's really refined carbs you want to avoid. Unrefined carbs, you should probably actually eat a certain amount to satisfy your need for glucose and craving for carbohydrates that humans naturally have. And while you can exist with no carbs, I don't think that's necessarily optimal for most people.
So you talked about, in the instance of cutting out carbs, taking protein and converting that to glucose. How much of that would happen on a more mixed diet? You use that 100 grams of carbs number. If somebody's consuming that within the day, how much of their protein would be converted to energy, if any?
A lot less, a lot less. So it's basically a demand driven process. You only convert the protein into glucose if you have to. So if you have a way higher glucose demands, you have to convert way more protein into glucose. So if you've basically achieved glycogen adequacy, so when you eat carbs and glucose, it's stored as glycogen in your muscle and in your liver. And once you've kind of tanked up your liver with maybe 100 grams of glycogen at the most it can hold. And your liver, your muscles can hold about 300 grams of glycogen. Once you've filled these up, you're basically set. You don't have to perform a lot of gluconeogenesis. And so that's why I think like eating a certain amount of carbohydrate is probably a good idea, just because you're going to spare protein and you're going to satisfy this basically appetite for carbohydrate that humans normally naturally have.
How do you feel about periodic ketosis and ketones being an important input, at least from time to time, on the system?
I think it's a good idea because I think that you want to be as metabolically flexible as possible. You want to be able to exist on anything. I want to be able to eat tons of carbs and not have a huge glucose excursion and just suck all that up into my liver and muscles, no problem. I want to be able to eat no carbs at all and just live off of stored body fat and ketosis. I want to be able to flip back and forth as fast as possible. The thinner you are, the leaner you are, the less fat in your adipocytes, the more metabolically flexible you're going to be. And you really achieve that by exercising a lot, having tons of muscle, and also eating a high satiety per calorie. So you're always kind of on the lower side when it comes to caloric intake. And then your fat cells are shrunk down and you have more room for storage in there. Your insulin sensitivity goes way up. Your metabolic flexibility goes way up. And then it doesn't matter if you eat all carbs, no carbs, some carbs, you're just kind of flexible and it doesn't really matter, which is, I think, where everybody wants to be.
Tying back to the low carb part of the conversation, somebody who is dampening their carb intake over time, they're actually going to produce less insulin over time. And if they do take in carbohydrates in a bolus, they could run into issues.
Wait, say that last part again.
If they've gone low carb for a period of time, they've adapted their system and their insulin production has been downregulated. So if they take in a bolus of carbs, their body, basically they've trained their body to be good at metabolizing fat, but not carbohydrates.
Oh, right. Yes, absolutely. Okay, so excellent point. Your body is just this survival machine, and everything is adapt or die, and you will get used to pretty much anything. That's why humans can live in any part of the globe, any extremes. We can make it work. We do have to do some adaptations to get there. So on a very, very low carbohydrate diet or zero, you have a lot of adaptive glucose sparing, where you're just basically never burning glucose because you're sparing it all for your brain. And instead, you're burning fat, you're burning ketones, um, your fasting blood sugar is going to be really, 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 really high at the very, very upper end of the normal range. But then after you eat, it's not going to go up at all. And so you'll just be like the same A1C and the same average glucose as someone who's eating a bunch of carbs, but nowhere near as many ups and downs. As a result, you get this physiologic insulin resistance where if you eat a bunch of carbohydrate, because you're not used to that and because it takes maybe days or a week or two to get your metabolic machinery kind of tuned to one extreme or the other, you get very carbohydrate intolerant, which basically means, if I take a animal that's a pure obligate carnivore like a cat or a dolphin, and I give them a bunch of carbs like soda or something, their blood sugar is going to just shoot way up into a diabetic range. Same thing with humans. If you're on a zero carb, pure carnivore diet and you haven't eaten any carbohydrate, when you do eat those carbs, your blood sugar is going to spike up hugely just because you're tuned for this glucose sparing mode. And it takes a little while to get out of that. You can actually do the reverse in pretty much any mammal, and that is carbosis, or basically carbohydrate training, where if I just feed you just all of your energy calories from dextrose, just sugar, 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 you get very carb adapted, and when you wake up in the morning, your blood sugar will be at the very, very lowest end of the normal range, the exact opposite of the carnivore who wakes up and their blood sugar is 100. Yours will be 70, 69. But then when you eat, your blood sugar will go up some, but not like crazy high like the adaptive glucose sparing carnivore who's in ketosis mode. So you can actually do carbohydrate training in mammals and get them over a week or two to the point where they can eat just huge quantities of sugar without their blood sugar going up very much at all. And then the opposite is true, where you can just fat adapt in a mammal where they're eating no carbs at all. And then when they do eat carbs, their blood sugar spikes up really high. So there's an inertia to your metabolism either way. And you can kind of tune it to one extreme or the other. I mean, personally, I like to stay just somewhere in the middle where you're eating a mixed diet and you're eating maybe half of your calories from carbs and the other half of your energy calories from carbs, the other half from fat. And that way you can kind of lean into either direction if you need to. But I think somewhere in the middle might be optimal for most people. And the extremes are merely possible, but probably not exactly optimal. Most things in life are on this U-shaped curve where the ends are possible, but you got a lot of diminishing returns, and the sweet spot is probably somewhere in the middle.
So what we're saying here in a nutshell is that whatever diet you end up going on long term, you're going to train your metabolism and it's going to evolve accordingly over time.
Right. Yeah. It's several days, better part of a week or two, to really kind of adapt to extremes of carb and fat. Exactly.
And when it comes to somebody being low carb, and say they do have that bolus of carbohydrate and their body has been adapted to be a fat burner and not handle that, does it come to insulin, the reason that it spikes like that? There's not enough insulin to regulate the glucose in the blood?
That's definitely part of it. So you get this first phase insulin response where the beta cells release this this insulin that's like sort of ready to go, and you get way less of that first phase response if you're on these very, very low carbohydrate diets. So yeah, that is absolutely part of what's going on. The other part is just glucose sparing mode, where all of your cells are just used to taking up ketones or fat, and they've got tons of fat present. And because of this Randle cycle phenomenon, you're kind of burning one or the other. And your cells will basically be sparing that glucose for your brain. And that's why your blood sugar might shoot way up. It's a combination of insulin and basically what the cells are taking in.
As you talked about the Randle cycle there, it got me thinking about one of the pillars of the PE diet where you don't want to mix fat and carbs. We've already talked about the fact that you need to balance those energy sources when, say, you're having a meal. But tying that to the Randle cycle, let's talk about why combining those in a moderate to larger amount within one meal would not be a good idea.
Okay, so combining them together is no problem from a metabolic standpoint. You only get these Randle cycle weirdness at the extremes of adaptation to low or high carb. Most people can eat a mixed meal, no problem. They eat carbs and fats every single meal. It's not an issue. They don't collide. They're not fighting each other. So you don't really have to worry about this Randle cycle stuff, and you can eat carbs and fats together. The only problem and in the PE diet, the only reason I'm worried about carbs and fats together is hedonics. So when you combine a high energy density carb and a high energy density fat together, you create something that's super tasty and delicious because it's almost never found in nature. So a lot of foods in nature are high in carbohydrate and a lot are high in fat, but almost nothing is high carb, high fat, high energy density all at the same time. The few exceptions would be mammalian milk, which is actually has a lot of milk fat and a lot of lactose. So you've got a ton of carbs and fats together, and then nuts, which is basically the plant equivalent of milk. And nuts are high in carb and high in fat and high in energy density at the same time. But this combination of high carb, high fat, high energy density is just super hedonic and drives overeating hedonically. And it's almost addictive because it spikes dopamine in your brain. These are your donuts and your potato chips and your French fries and your cakes and your cookies and your pies and your muffins and your crackers and your all these things are like high carb, high fat, high energy density all together, which I call the trifecta in the book. And it's all just basically all of your desserts and all of your cookies and all of the things that people are addicted to or binge eat or overeat or are super drawn to. So the protein dilution, people eat for two reasons. They need to eat or they want to eat. The protein dilution, you need to eat to get enough protein, so you're going to overeat from that perspective. But wanting to eat is going to also drive you to overeat from another direction. And there's like this push and pull to obesity. You're driven or pushed to overeat calories because you're eating a protein dilute food and you haven't gotten enough protein yet. But then you're pulled to overeat more because, even though you had steak and a salad and plenty of protein, when the dessert tray comes out, that's just super hedonic, and everything on there is high carb, high fat, high energy density all at the same time, like ice cream and cookies. And like you're just going to overeat that stuff because it's so tasty and delicious and rewarding and dopamine spiking. So I'm only worried about high carb, high fat, high energy density together from a hedonic, tasty, overeating dopamine point of view, not at all because of Randle cycle or some crazy cellular metabolism issue. That's really not the problem. The problem is just overeating in general due to hedonics.
Okay, talk more about the Randle cycle piece, though, so I understand that. Not an issue in an acute sense if we're having carbs with fat in a meal in a moderate to large amount.
Right.
But then when does that become a thing to factor in?
Got it. So that's the way your body works. Okay. So you have a very limited storage for carbohydrate in your body. You can hold maybe 100 grams in your liver, maybe 300 grams in your muscle. Let's say my muscle is filled with glycogen because I haven't, your body holds on to that for emergency use. That's what you're using if you're sprinting for your life, if you have to run from a bear or something. So if I'm not doing high intensity exercise, my muscle is just basically filled with glycogen most of the time, or it has glycogen in it. The liver, when you eat carbs, the liver's default state is empty of glycogen, and then it's there to buffer carbohydrate out from your food. So when I eat my 100 grams of carbs, I fill up my liver glycogen, and then that slowly drifts down to zero over the next 12 to 24 hours or so. So after 24 hours of not eating carbohydrate, your liver glycogen is basically as low as it gets. And you're going to enter ketosis. Low liver glycogen is basically the switch from burning more glucose in your bloodstream to just burning fat. And that's the default state for humans who aren't eating. You're just burning fat. So I've fasted for 24 hours, liver glycogen zero. I'm pretty much just exclusively burning fat, right? When I eat carbohydrate, I will fill that liver glycogen up. But as I eat more and more carbohydrate, because I have a finite storage for it, I will switch my whole metabolism to more glucose burning and less fat until the carbohydrates that I ate are gone. And then I just smoothly switch back and forth. So it's like this teeter totter or this seesaw where the default state is eating or burning fat. But as you eat more and more carbohydrate, you switch the entire body metabolism over to burning glucose until that energy is gone, and then you shift right back to fat. The extreme example of this is alcohol. So you have zero storage in your body for alcohol. It is the macronutrient with the highest priority, which means it all has to be burned off before you burn anything else. So let's say I'm just burning fat. I drink a bunch of alcohol. As the alcohol presence gets higher and higher in my bloodstream, all my fat oxidation throughout my body goes down until all that alcohol is burned off. And then I smoothly shift back over. So you're basically displacing fat oxidation when you eat macros that have to be burned off and can't be stored. And that happens with alcohol. That happens with glucose. That happens with protein. If I'm just drinking hundreds of grams of protein from a whey shake or something, I do have to dispose of those carbons, and I will actually burn that protein more for energy until it's gone, or as it's leaving, I smoothly shift back over to fat. And you never have to really worry about this. Your body is just doing this in the background. And it's just very smooth displacement of fat oxidation with other higher priority macronutrients like glucose or ketones or alcohol, and then smoothly shifting back when those the presence of those goes down in the bloodstream. And this does use insulin and glucagon to function, but it's basically something that your body just does automatically. And as long as you're not a type 1 diabetic or something with no insulin, then you really don't have to worry about this. And these fuels aren't, colliding or something like that. So most people who are thin and insulin sensitive and healthy and have plenty of storage room for glucose in their liver and muscles, and plenty of room for fat storage in their fat cells, can just switch back and forth, carbs, fat, doesn't matter. Their metabolism will smoothly shift back and forth. They will store any excess fat in their fat cells because they have plenty of room. They will store any extra glucose in their liver and muscles because they have plenty of room. And it's never a problem. The problem is when you're insulin resistant. You get insulin resistant when those three storage depots, fat cells, muscle cells, and liver cells, all start filling up. So as your fat cells have a maximum diameter. As they approach that maximum diameter, they start refusing more and more fat, and fat just circulates in your bloodstream. Once that gets high enough, then none of your cells want fat or glucose. Then your blood sugar starts going up. Then your insulin's high all the time because insulin's trying to clear fuels out of the circulation. In order to be fully diabetic, type 2 diabetic with high glucose, your fat cells have to be mostly full. Your liver has to be mostly full. Your muscles have to be mostly full. 100% of type 2 diabetics have fatty liver. So you basically fill up all the storage depot. And then when you eat even more carbs and fats, they just circulate in your bloodstream. They have no place to go. Insulin is getting higher and higher and higher, desperately trying to clear these fuels out of circulation. But all your cells are ignoring it. They're like, look, I already have too much fat and glucose. I'm not taking anything. So that's why your triglycerides are super high, and then your glucose is super high. And then you get all these toxicities from excess energy. It breaks your mitochondria and causes all kinds of havoc pretty much. But that's what's going on with insulin resistance, is really just running out of storage space. If you're super thin and all your fat cells are small to medium diameter, and you have tons of skeletal muscle and lots of room to store more glycogen, and you're not constantly eating, so your liver doesn't have a bunch of fat in it, then you've got plenty of room to dispose of incoming macronutrients. And you can eat tons of carbs, your blood sugar barely goes up at all. You can eat tons of fat, your triglycerides barely go up at all. We do these, I'm sure you've seen like a glucose tolerance test where someone ingests 75 grams of glucose and we watch their sugar go up and back down. We do the same thing with an oral fat tolerance test where you drink 75 grams of heavy cream, your triglycerides go up and come back down. if you're super lean and active and healthy and have good body composition, tons of muscle, small fat cells, you can eat all of this like fat or carbs or both, and you have just these minimal excursions of triglycerides and glucose, and you're totally fine. You're totally metabolically sensitive. You can do anything you want with your diet. You never have to worry about any of this. If you're over fat, your fat cells are approaching their maximum diameter, your muscle cells are full because you never do any high intensity exercise, your liver is totally full because you're just like, way too many calories all the time, then you're going to have huge triglyceride excursions when you eat fat. You're going to have huge glucose excursions when you eat carbs. You eat fat and carbs together, you get this massive like spike, plateau, everything's high all the time. Everything's high, not just blood sugar. It's triglycerides, free fatty acids, glucose, all the fuels in your circulation. So that's the problem with basically overeating and running out of storage space. And then you have all these issues. But really, it's not the Randle cycle that's causing any of these problems. That's just smoothly allowing your body to switch back and forth.
Let's talk about that patient who is insulin resistant, has their fat cells are full, their liver is full of fat, their muscles full of fat. They come to see you. Does the PE diet change if somebody is metabolically unhealthy? And what we've talked about to this point is that for the metabolically healthy person. What I'm getting at here in a nutshell is, does the diet change depending on where someone falls on that spectrum of metabolic health to dysfunction?
Absolutely not. Not at all. Zero, period. Your whole goal in life is to get the highest lean mass at the lowest fat mass. Basically, you want to be a bodybuilder. So if I just snap my fingers and you're a bodybuilder, you have very little body fat, tons of muscle. This is the very best metabolic situation of all, because you can dispose of all kinds of energy in your muscles, mostly glucose and glycogen, but also some intramuscular triglycerides. When you eat a ton of fat, your fat cells all just hoover it out of your bloodstream on the first pass. And so like a stage lean bodybuilder can eat a massive amount of fat, and their oral fat tolerance tests, they just get a tiny spike of triglycerides and it goes right back down. They might have, fasting triglycerides at 30. And if they drank 75 grams of heavy cream, it might be 40 or 50, right back to 30 again. Their fat cells are so insulin sensitive, it just sucks all the fat right out of their bloodstream the first pass. They have very low insulin, very low triglycerides, very low glucose. Everything's very low. And that's because they have shrunk down all their fat cells, built tons of muscle cells, and that's absolutely where you want to be metabolically. All of your type 2 diabetics are the opposite of bodybuilders. They have exactly the opposite. They're usually sarcopenic, very little muscle, hardly ever exercise, no place to dispose of anything in their muscles. And then their fat cells are all just maxed out. If you look at the average diameter of adipocytes in type 2 diabetics, it's double that of normal non-diabetic population. So that basically their fat cells are all maxed out. And that is why they can't dispose of any calories, because they have no place to put it. Now, you could take this uncontrolled diabetic. The fastest way to make them non-diabetic is a glycogen depletion workout. If I took a uncontrolled diabetic, and had them just do the hardest CrossFit of their life for 2 hours, this is a glycogen depletion protocol, where you just basically 2 hours of just killing yourself in the gym will suck all the glycogen out of your muscles. And guess what? You're instantly non-diabetic temporarily until the next time you eat, and then you're basically going to be diabetic again. Same thing. You could fast for 24 hours. All the fat and glycogen drains out of your liver, and you're pretty much not as diabetic after that. I mean, it's a little slower than the muscle trick. That's the fastest. But, most diabetics who fast for 24 hours, they're going to have a significant lowering of their blood sugar. The real problem is slowly shrinking down all your fat cells, because in order to do that, it's just calorie balance. You have to eat less and move more pretty much every day for a really long time. And that is because you can't just take the food you're eating now and eat half as much. It's not going to work. You're starving to death. You're already eating to satiety of the foods you're eating now. So you have to intentionally choose foods that provide higher satiety for less calories, so you can still eat until you're full and satisfied, which you're going to do anyway. But you just automatically eat less calories. You do that by eating higher protein percent, higher fiber, more water, less energy density of your food, less hedonic food. And it's kind of all of these things at the same time. And that will slowly shrink down your fat cells. Of course, the more exercise you do, the better, because resistance training builds muscle, which is metabolic health. Basically, you have more glucose disposal. Most of your glucose is disposed in your skeletal muscles. So resistance training builds muscle. You're metabolically healthier. And then cardio just burns a bunch of calories. And so if anytime you can change that calorie balance equation, eating less, moving more, you're going to be better off from a fat cell perspective. You're just basically burning fat instead of storing it. So that's why the secret to diabetes is basically to be a bodybuilder. You're trying to do resistance training to get more muscle. You're trying to do cardio to deplete more calories out of your muscle. And then you're trying to eat the diet that has the highest protein percent, because protein supports your lean mass, and then the least carbs and fats, because carbs and fats support your fat mass. Your fat, all the fat you eat gets stored as fat, and all the carbs you eat displace fat oxidation via the Randle cycle. So carbs and fats are there to support your stored energy, fat mass, and protein is there to support your lean mass. So the PE diet makes perfect sense for basically anybody, anytime, anywhere. And it's all about prioritizing lean mass over fat mass.
I'm just trying to think of arguments from the low carb camp. If somebody has, say, type 2 diabetes, I would assume they would say we want to go low carb or no carb because that's going to have the biggest impact on insulin. And if this person is metabolically unhealthy with type 2 diabetes, they have way too much insulin. We want to bring that down as quickly as possible. Can you see how there could be an argument for that versus the PE diet if somebody's type 2 diabetic? And I know what your answer is going to be, but I want to know, as a thought experiment, we know that carbs have the biggest insulin spike, followed by protein, followed by fat, very little there. The argument again from the low carb would be, let's just get rid of carbs and let's bring that insulin down as quickly as possible. Why would you look at that differently?
Right. And there's nothing wrong with that approach. I mean, it's absolutely true that carbohydrates going to raise your sugar the most. And so focusing on the low carb side is going to get your glucose down faster. And it's going to also get your A1C down faster. But when it comes to just the global situation of overfatness, they're kind of interchangeable, carbs and fats. Part of what's going on here is let's look at somebody who's just severely diabetic. How much glucose is in their body? You're supposed to have 5 grams in your bloodstream. Let's say they have 10 grams in their bloodstream. Your skeletal muscle is supposed to store 300 grams. Let's say they're under muscled and they maybe even have less than that, but it's totally full. Where else, they're only going to have 100 grams of glycogen in their liver. That's it. So basically, there's not more glucose or glycogen in this person's body than average, except a couple extra grams. But now let's look at the fat side. They're just like swimming in fat. They're just massively over fat. Every fat cell under their skin, maximum diameter. Then they've had to store it viscerally. Every visceral cell maxed out. Then they've had to shove fat into their liver and into their muscles and into their pancreas. You get fatty organs. You get fat everywhere. You've got ectopic fat. And then you're diabetic. And so the underwater part of the iceberg is over fatness. Just fat. All the cells only start refusing glucose when they're already filled with fat. You just can't take any more fat. So that's when they're like, I'm also not going to take glucose. Everybody who's diabetic had increased waist circumference for years before their glucose went up at all. Super high triglycerides for years before their blood sugar went up at all. The base of the problem is over fatness, and almost all stored fat comes from dietary fat. So when you look at it like globally, you're over fat because you ate too many non-protein energy calories, carbs or fats. Then it's kind of like, okay, you could go low carb or low fat. Either is going to work. The best is probably a little bit of both. I do like low carb approaches for people with diabetes, especially type 1 diabetics, because when you're injecting insulin under the skin, you're peripherally administering something that's supposed to be coming from the beta cells in your pancreas and bathing the alpha cells and tamping down glucagon. And the peripherally administered insulin is never going to be nearly as good as centrally delivered pancreatic insulin. And for that reason, you want the least inputs and the least insulin requirements that you can get. So I like very low carb diets for type 1s. I like very small doses of insulin. But you still want to be a bodybuilder with as much muscle as possible, doing as much exercise as possible, and eating as few extra carb or fat grams as possible. So the basic PE template works for everybody. Although, yes, if you're a diabetic with extreme blood sugar or type 1, I can see how low carb would actually be even more important. So I can kind of go where you're going with that. I don't really have a problem with that. And in fact, I did come from all this from the low carb side of things. So that appeals to me and my biases. But I do know that big picture, the carbs and fats are more or less interchangeable. Also, your body's not going to make more insulin than it absolutely has to. And if you're overeating fat or any macronutrient, your insulin will be high all the time. And the problem with type 2 diabetes is that basal insulin is just super high all the time, whether you're eating or not. The mealtime insulin is actually maybe 20% of the contribution to your overall insulin area under the curve. So if I replace carbs with fat, my basal insulin goes up from the fat, my postprandial goes up with the carbs, and the area under the curve is almost exactly the same either way. So big picture, not a big deal, carbs versus fats. You want to lower both. Very short term, yeah, I can see going low carb first. That makes some sense to me.
Let's talk more about the type 1 diabetic you brought up there. Oftentimes, this part of the conversation is steered almost entirely to type 2, understandably, but there is still a significant amount of people that have type 1, the autoimmune, where their beta cells aren't producing insulin. Talk about what happens when somebody goes to a PE diet if they're type 1. What changes are they going to have physiology-wise? And what outcomes have you seen with patients?
Got it. Okay, so if you're type 1, I do like a lower carb approach just because of the inefficiencies with peripherally administered subcutaneous insulin when it's supposed to be coming centrally from your pancreas, bathing your alpha cells, tamping down glucagon. So you really want low carb inputs and low insulin doses. But even bigger, even more important is body composition and insulin sensitivity. So I've got type 1s who have amazing body composition. They're basically like bodybuilders or bikini models. They're eating tons of protein, doing tons of resistance training, tons of cardio, keeping the carbs and the fats really low, very high satiety per calorie diet with high protein, high fiber, high water, low energy density, low hedonics. They're super lean. They are maybe living on 20 units of insulin a day total or less. I mean, I've had patients whose, basal insulin is like 16 units a day, full grown adults, because they're super thin, super insulin sensitive, tons of room for storage in their liver and their muscles and their fat cells. And they're doing cardio where you actually shuttle glucose into the muscle cells without needing any insulin at all. And so if you're firing on all cylinders, PE diet to keep you super lean and keep your satiety per calorie super high and eating as few calories as possible, and then keeping the carbs low because you're just never going to match those well with injected insulin under your skin, then you're going to have really flat glycemic curves. You're going to have super low A1C. You're going to have really good everything. And your insulin requirement is going to be super low. Contrasted to some of my other type 1 diabetics, half the type 1s I've got who are just like not into any of this diet stuff. They're just injecting a bunch of insulin. They basically have type 2 diabetes on top of type 1. They're over fat. They're under muscled. They have huge insulin requirements. I have type 1 diabetics using hundreds of units of insulin a day, like literally 100, 200, 300. Sometimes we have to give them, instead of the standard U100 insulin, we give them U500 insulin. It's like this 5x hyper concentrated insulin. And they're so overfat and insulin resistant, they're just using these massive doses of insulin. And it just gets worse and worse the more overfat you are. So it really, this body composition piece is huge for type 1s. You want to be as thin and well muscled and active as possible to have the ultimate insulin sensitivity and have the very lowest insulin requirements. You do want to keep the carbs low, but you want to keep the fat low as well, so you're super lean. Also, eating tons of fat does make your insulin resistance go up. And so you really want to be low carb and low fat at the same time, which is basically what the PE diet is. So it's almost as big a deal for type 1s as it is for type 2s. I'm going to say it's just as big a deal as it is for type 2s. So, but there's really not a lot of difference to the diet either way. What I'm recommending to a type 1, type 2, normal healthy person, very, very similar, all sort of a PE approach, with the only caveat being that if you have an autoimmune type 1 and you make no insulin in your pancreas at all, you might want to keep the carb inputs as small as possible because you're not getting that nice little mealtime spike of insulin from inside your pancreas. You have to inject it through your skin, and it takes forever to really work, and it's not shutting down your alpha cells and your glucagon very well. So just because of the inefficiencies of peripherally administered insulin, the fewer carbs, probably the better.
For somebody who takes on what we're talking about diet-wise, you mentioned putting on muscle. How quickly can they turn around their metabolic health? Somebody who's, say, type 2 diabetic and they start implementing a lot of this.
Well, exercise is the absolute fastest. So your fastest way to be non-diabetic is exercise. Resistance training for more muscle, cardio to deplete that muscle. You really want to be doing 3 forms of exercise: general movement, that's hitting your step count of 10,000 a day; full body, high intensity resistance training to maximally stimulate muscle. That's basically lifting to failure at least twice a week, push pull legs. And then some sort of cardio. You should be doing half an hour of at least moderate intensity cardio or higher 5+ days a week, and you're just depleting your muscles of fuels, and this depletion is very, very good for you metabolically. So exercise is the fastest way to be non-diabetic. The problem is you can just kind of eat your way right past that because it might take me several hours to run a marathon and burn 2,000 calories, but then I can eat 2,000 calories from a dozen Krispy Kreme donuts in like a minute and a half. So you could just undo all that with your diet even faster. So the fastest way to be non-diabetic is exercise, but the diet part is also really, really critical. So you definitely have to nail both of those together. And honestly, health is 50-50 diet and exercise. You can't really say one over the other because it's just a yin and yang. It's a mistake to focus on one and not the other. Anyone out there who's just really geeked out about their diet but is never exercising needs to just forget about their diet and put all their energy into the exercise part. Anyone who's just exercising a ton but then eats whatever they want, they need to focus on the diet part. You don't want a unifocal over-reliance on one or the other. You want to be doing both. But you could very, very fast normalize diabetes. I have patients who come in and I diagnose them with new diabetes and they had no idea. They didn't know they had metabolic syndrome for the past 10 or 20 years from overfatness. They didn't know that they then pushed over and become diabetic. And they're not watching their diet. They're not exercising. They're not doing any of this stuff. If I educate them about all the lifestyle parts and they just successfully implement it, I've had people be just completely non-diabetic in several weeks. It's astounding how fast you can reverse this if you go from just eating the same crap everybody else is eating mindlessly and just sitting on the couch, and not exercising, to really being intentional and basically just pretending you're a bodybuilder, a bikini model, and eating the whey shakes and the skinless chicken breasts and the broccoli and doing the cardio and getting on the treadmill and lifting the weights. If you really start doing all these things, you can reverse diabetes like that. And I have people doing that all the time.
So for somebody who is metabolically unhealthy and they want to make these changes, or just somebody, again, you've stressed the importance of what we're talking about for the person who is sick or somebody that just wants to maintain their health. What are the other lifestyle pieces besides diet and exercise that you'll recommend to somebody?
That's pretty much it. I mean, other things are important. It's important to get enough sleep. So sure, yeah, it's important to have good relationships. It's important to have a sense of purpose. It's important to have good mental health. So yes, you should prioritize sleep. You should see a therapist. You should work on your relationships. You should, focus on things that give you purpose in life. You should surround yourself with friends and family, blah, blah, blah. None of those are really as actionable, I've found, as diet and exercise. And those are the two biggest rocks in the jar for sure. The other rocks are important, and you absolutely have to take those into consideration. But for most of your type 2 diabetics, it's the diet and exercise that are the biggest things to focus on. And you could reverse your diabetes focusing on those, even if you didn't have all those other things completely dialed in. For me, those are style points that you would layer on top of a really foundational diet and exercise.
And arguably for somebody who this is all new to, you wouldn't want to throw too many different variables at them in the beginning and throw them off course.
Right. And it's just like lifting weights where you want to just progressively overload. You don't want to just tell people, okay, you've never bench pressed before. Here's 500 pounds, go. You want to, just start with the bar and the movement. You do the same thing with your diet. You're just like, I'm going to eat all the same stuff I eat now and just switch from regular soda to diet soda. I could do that. That's actually realistic. I could just switch from the fattiest meat I can find, bologna, hot dogs, super cheap ground beef, to leaner proteins. I could actually get, the Canadian bacon instead of the real bacon, the 90% lean ground beef instead of the real ground beef. I could actually cut down on my carbs a little by just getting the whole wheat bun, the low carb bun instead of the white bread. You know what I mean? I could just make these little tweaks that are sustainable and directionally going to help me out, but in a slow and progressive fashion. You start out with just little things. You're like, okay, I'm going to do 15 minutes of exercise a day. That's it. I'm just going to start out walking. I'm going to just do a couple push-ups. But then you progressively overload that. Once that's easy for you, you just crank the speed up on the treadmill a little. You crank the incline up a little bit. You do a few more push-ups, and then like a year later, you're addicted to exercise. You're running at a 12% incline for 15 minutes every day, and that's 2 miles and 500 calories. You're doing you're doing 30 one-arm push-ups on each side. You're doing pull-ups. You're doing, single leg squats. You're doing all this stuff, and you started out really small and you have a fairly small time investment, but you just progressively overload it and make it harder and harder and harder. Same thing with the diet. You started out by just eating, diet soda instead of regular soda. And now next thing you know, you have salads, you got low calorie dressing, you're drinking whey shakes, you're eating skinless chicken breast, you're just eating, everything you eat, you're trying to add less fat, less refined carbs. And you can progressively overload all this stuff. And when you look at the spectrum of like your average person, and then your uncontrolled type 2 diabetic over here, and then you're just like ripped and jacked bikini model over here, it's really just this progression of diet and exercise. And it's really just cardio, resistance, general movement on the exercise side, and then low carb, low fat, high protein on the diet side. And once you just like start pulling all those levers a little bit and progressively overload them, the sky's the limit.
Early in our conversation, we talked about the fact that if somebody is changing their diet, upping their protein, micronutrients aren't a concern, which brings up for me supplements. Somebody who is sick or healthy and wants to maintain, any supplements they'd want to consider?
Basically, no. If you're a pure carnivore, yeah, you're going to be low on folate. You're going to be low on magnesium. If you're a pure vegan, yep, you're going to be low on iron, B12, zinc, selenium. But I don't really recommend those. Like, while those are possible, optimal is somewhere in the middle, being an omnivore. You're a healthy person who has a reasonable diet quality omnivore. They really don't need to supplement. Especially if they're exercising. One of the problems with, let's say I never exercise, I have to shrink my calories down to, 1,600 a day to lose weight. okay, then I might start having some issues getting enough micronutrients. But if I'm doing an extra 500 calories of cardio every day, oh, I can eat a lot more. And all of a sudden, I don't have those micronutrient concerns. So um, it's the same thing with diet and exercise. You want to be somewhere in the middle. You don't want to be doing just one or the other. Just like you don't want to be pure plants or pure animals. Optimal is always somewhere in between. If you're a omnivore and you're mixing diet and exercise, your average healthy person needs no supplements whatsoever. I never take any supplements, never have. I don't really recommend them. Most of them are not evidence based. Most of them have not been shown to improve outcomes for the average person. So you really only have to supplement if there's something wrong with you or you're somewhere on the fringe. I do have patients, with pernicious anemia and they need B12 supplements, or are, religious vegans and they do have issues with these, some of these micronutrients. So, but like if you're somewhere in between and reasonably healthy, you really don't have to be supplementing, especially if you're prioritizing protein, which, like I said before, most of your macros are going to track with that.
And how do you feel about these different biohacks out there? Red light, saunas, cold plunges. There's this whole other aspect in the health and wellness space that has a ton of momentum. Do you feel like any of that is valuable?
These are all 1% things, if that. Like, so many people are majoring in the minors. Okay, like get your cardio completely dialed. Build your endurance way up, have a crazy awesome VO2 max, be completely ripped and jacked with diet and exercise, and then come back and talk to me about your sauna and your red light and your cold plunge and your blah, 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 which is literally less than 1% for sure. And the smallest rocks in the jar, it maybe just gravel or sand. So I don't do any of that crap. And not that I think it's not valuable. It's just because I have a finite amount of energy and willpower and things to focus on. I am going to put all of that energy into the things that move the needle the most, the biggest levers. I'm putting that into diet and exercise. And I would really only focus on those once diet and exercise were completely dialed, which they probably never will be. So yeah, it's not worth focusing on for your average person. Like if you're already perfect on lifestyle, diet and exercise, sure, okay, then worry about your blue blockers and your meditation journal and your cold plunges and your sauna and your whatever. But most of that is basically not helpful for your average person. My patients are they're working two jobs. They're trying to survive. They've got kids. They're basically in survival mode and they don't have the luxury of time and money and resources to, basically do all your Huberman protocols. And they just don't have that kind of luxury. So that's really kind of not going to help your average person, in my opinion.
And I could see how that could be a trap for a lot of people too, who are new to this, who get involved maybe in some of those things, whether it be a cold plunge or sauna, cold showers. We could go on and on. And then they're not doing the diet. Again, you only have a certain amount of energy, time, money. And if we're neglecting the diet, the exercise, we can feel like we're doing a lot, but not seeing the changes. And it could even be doing a disservice overall.
Right. Like, in the book, I'm all about that Pareto principle where you want to put 20% of your effort into the things that are going to get you 80% of your results. And you're just so much better off because time and money and focus and willpower and brain cycles are very finite resources. You want to pour those into the things that are going to get you the largest return on investment. And that's cardio, resistance, general movement, protein prioritization, low carbon, low fat, satiety per calorie. You're really wanting to focus on those, and everything else is possibly distracting in an almost negative way if you're putting that before some of the bigger levers, in my opinion.
How do you feel about getting lab work done as somebody who comes to you metabolically sick? And again, for the healthy person, say yearly getting blood work done to see where their levels are. And then on top of that, what changes might they expect changing their diet and lifestyle like we're talking about?
Yeah. So when I first started out and I didn't really know as much, I had all this functional medicine training and I was checking all these weird labs and all this stuff. And as I get older and wiser, I realize most of that crap doesn't add anything valuable. It's just not that helpful. So the list of things I check just gets smaller and smaller and smaller every year. And from a metabolic health perspective, I'm mostly just looking at fasting glucose, fasting lipids, A1C. I can tell most of what I need to know just looking at waist to height ratios, measuring waist circumferences. But then things that I pay attention to are fasting triglycerides. You want this as low as possible, lower is better. A1C is important. Um, and then there's not a ton of other stuff that's that helpful. Of course, I'm checking people's blood counts and liver and kidneys. And so a lot of people do, check thyroid, complete blood count, comprehensive metabolic panel, lipids, cancer screening. But I'm not doing a lot of other fancy tests on top of that because I usually know just by looking at people naked and looking at waist to height ratios, whether they're over fat or not. And having a number to demonstrate that is sort of helpful, but not crazy helpful for the average person. It's like you could just look in the mirror and know if you need to work on building more muscle and losing more fat. And spoiler alert, that's every single person out there. Basically, everyone who walks in the clinic needs more muscle and less fat. And it's a constant daily struggle in a Sisyphean fashion. And that's pretty much everybody. Of course, if someone's like horrifically diabetic or using medications and things like that, or if they have some other specific thing going on. But for your average person, more lab work is not helpful. And I hate to say it, but if you go see a naturopath who isn't quite sure what they're doing, they're going to shotgun a million labs and do thousands of dollars worth of testing, none of which is helpful or value added. I mean, at the end of the day, it's really just diet, exercise, get a higher lean mass, lower fat mass, the end. And all the labs in the world aren't going to help your average person accomplish that. So lab testing, while I do it, I recommend it yearly, some basic stuff, and I do that all day, all the time. I'm not really into a bunch of other weird stuff because it's just not evidence-based, not value-added. And again, usually majoring in the minors or not actionable.
For somebody who is somewhere on that spectrum, which is most people, from insulin resistance all the way to type 2 diabetic, and they've now gotten to the point where their fat cells have been, enlarged. They have visceral fat. Their liver's taking on fat, their muscles. Talk about some of the complications to give people the motivation to do what we're talking about today, who feel like, okay, this is just who I am. We're in this world today where it's politically incorrect to, point out people that are overweight, obese. So there's that whole layer on top of it as well. But there is things like lab work and scans, MRIs, DEXA scans. We can see biological, physiologic changes in people when they are accumulating this fat through their body. So let's talk about why, if somebody is just at that point and they're kind of on the fence here, they want to take care of that. It's not something just to let go.
Right. Okay, so insulin resistance, right? Anyone who's over fat, their fasting insulin will be higher than it should be. Their postprandial insulin will be higher than it should be. And that's basically because they can't dispose of incoming fuels very well because their fat cells are mostly full, their liver is mostly full, their muscles are mostly full. And the fuller these storage depots get, the higher your insulin has to be to try to clear fuels out of the circulation, but it can't. So if I have someone who's super lean and super healthy and has very small fat cells and tons of muscle and this healthy bodybuilding person, their fasting insulin might be a 1, right? But then like average in the US, 15 years ago, it was 8 or 9. Now it's like 12 or 13. Fasting insulin, normal, just keeps going higher and higher and higher. I've got patients who come in, their fasting insulin's 30 or 50 or 70. Now I don't even measure it anymore because it's just, if your triglycerides are too high and your waist circumference is too high, your fasting insulin is going to be too high. And who cares? We already knew that. So, but this insulin resistance is really just a marker for overfatness. And that's your metabolic syndrome. These people have, metabolic syndrome is high waist circumference measured at the belly button, high triglycerides, low HDL, high blood pressure, eventually high glucose. And it's really a metabolic toxicity where you have too many fuels in the bloodstream all the time. And over time, this raises your risk for every single chronic degenerative disease you could possibly name. Cardiovascular disease, radically higher with insulin resistance. Neurodegenerative diseases like Alzheimer's, Parkinson's, ALS, way higher with if you're insulin resistant. If you're an ApoE44 and you're insulin resistant, you've got like a 50x risk for Alzheimer's dementia. It's absolutely absurd. Cancer risk, all of your incidence of cancer goes way up with metabolic syndrome. Cancer deaths go way up with metabolic syndrome. Any form of cardiovascular, major adverse cardiovascular event, heart attack, strokes, coronary disease, way higher with metabolic syndrome. Insulin resistance drives every single chronic degenerative disease you could think of, osteoarthritis. Also, your common ailments, your acid reflux and your joint pain and your back pain and your heartburn and your autoimmune diseases, asthma, ulcerative colitis, Crohn's disease, rheumatoid arthritis. You can look at symptom scores of autoimmune disease and fasting insulin, and it's just a straight line going up. The more insulin resistant you are, the worse your autoimmune disease is going to be. Fat loss via any mechanism improves almost every autoimmune disease, full stop. So this overfatness and insulin resistance and energy toxicity drives all of these chronic diseases, pretty much everything you could think of. The other thing that happens, and we can't even really measure this, is mitochondria. Okay, so about 10% of your body mass should be mitochondria. These are the energy producing factories in all the cells of your body, right? Or most all of the cells of your body. And when you have a metabolic oversupply to your mitochondria, basically, if you're eating too much and not moving enough, so there's just always too much energy present, which is what you have with metabolic syndrome or insulin resistance. This metabolic oversupply damages your mitochondria. You get smaller mitochondria, fewer mitochondria, lower mitochondrial contents, lower mitochondrial function. If I do a muscle biopsy on a type 2 diabetic who's horribly energy toxic, everything about their mitochondria is worse. Fewer, smaller, less contents, less active, less everything. The actual mass of mitochondria in their body goes in. You can actually build up your mitochondria with metabolic undersupply. So if I, shave my calories way down and then do a ton of exercise and have an energy demand, if I'm basically undersupplying and I need way more energy, the exact same thing gets driven in reverse. Your mitochondria, you undergo mitochondrial biogenesis. You could double the number of mitochondria you have. A healthy person who trains regularly, has good body composition, might have twice the mitochondria of the diabetic. The mitochondria are also bigger, more effective, more efficient, larger contents, larger mitochondrial act. Anything you can measure about mitochondria is better. This is stuff that you can't evaluate in the clinic or on your own. This is just a pure research level thing. We have to do muscle biopsies and then do this fancy mitochondrial DNA analysis or look at it under scanning electron microscopes or just do some crazy research stuff to even know this is happening. But your thin and ripped and jacked bodybuilder is going to have way better, way more mitochondria because of metabolic undersupply. They're demanding way more energy and they're providing way less energy versus your diabetic who's the exact opposite. And this affects every part of your life. It's just general energy levels. People come in, they're like, I'm just tired all the time. Of course I can't exercise. I'm just exhausted. I'm tired when I wake up. I'm tired when I go to bed. I'm tired all the time. When I try to work out, I'm pretty feeble. I can't generate a lot of wattage. It's just everything makes me tired. I'm depressed. This is this mitochondrial thing that I don't even have a way to evaluate in the clinic. I just know it's happening. I just know you've broken these mitochondria with metabolic oversupply, basically eating too much and moving too little. And I also know that these people who are like, wow, you know what? I changed my diet and exercise. I lost a bunch of weight. And now I feel amazing. Like my energy level just skyrocketed. I feel like I could just run through a wall. And it's just, everything I do is easier and better, and I feel better. A lot of this is mitochondrial, except it's purely theoretical. There's absolutely no way for you to know how this is happening or what's going on. All you can do is eat less calories so you're undersupplying and just be as thin as possible. And then move more, cardio, resistance, general movement, to demand more energy. And that is going to optimize your mitochondrial health. Except it sounds like a woo thing because we don't have a test for that. There's no way to evaluate. You can't just measure your mitochondria with like a measuring tape. You can't just do a blood test. So this is like, it sounds stupid. It sounds like energy. When people talk about energy and things of that you can't really see or measure. It just sounds like a bunch of woo bullshit and garbage. And so I kind of get that. And it sort of is because you can't actually really evaluate this. But the general concept is the thinner and more insulin sensitive you are, and the more you move and the more muscle you have, the better your quality of life is going to be in every way. You're just going to have more energy. You're going to be able to pump out more wattage. You're just going to be able to do more stuff. And a lot of that is mitochondrial, but you'll never be able to actually evaluate that. So once again, like your goal is to always have the highest lean mass and lowest fat mass. Your goal is also to have the most mitochondria. This is probably why birds live longer than any other animal, way out of proportion to how long they should live, right? So like you have this graph of like how long mammals live based on their size and all these things. But then like birds are just way off the curve because they're just like living insane lifespans for their size and their brain size and their body size. They should absolutely not live as long as they do. And the reason is they just have crazy amounts of mitochondria and huge mitochondrial densities. And it's because they have to freaking fly, right? When you're flying, your strength to weight ratio is off the charts. The amount of wattage you have to immediately pump out all the time is crazy. They're always just trying to get enough calories to get by, right? So it's this super high mitochondrial density that is probably part of why they have these incredible lifespans. And if you had to like generate enough wattage to lift your body off the ground, 10,000 times a day or whatever these birds are doing, it would be a crazy demand for energy that you would really struggle to match with your diet. Like if you look at a hummingbird and the amount of energy flux going through that hummingbird every day is absolutely insane. Every single day they eat so many calories that they get an extreme case of fatty liver. And then every single day they just burn off like an absurd amount of calories. And then they just have these crazy mitochondrial densities and the really long lifespans. And it's all just very high energy flux. They're eating a lot and burning a lot. And so the point here is that if you can demand a bunch of energy from your body, but then not oversupply it metabolically, you're just going to get more and more mitochondria, which is going to help your entire lifespan and your health span, and everything's going to be better.
One thing I want to add to that too is somebody who's tuning in and they're looking at themselves in the mirror and saying, okay, I'm not overly fat. My energy's okay. I don't really need to worry about this. There is a genetic factor as well. And you might not have a lot of subcutaneous fat that shows, but yet you can still be a metabolic mess inside and this stuff can still be happening.
Yeah, absolutely. Right. Some people have just genetically very little subcutaneous fat. This is the personal fat threshold. It's super genetic. Look at people from Southeast Asia. They will never, ever get a bunch of excessive subcutaneous body fat. So they look pretty thin. But if you actually measure their waist circumference at the belly button, it's like way bigger than it should be. They've got this little pot belly. And then if you scan them and look at visceral fat, it's way higher percentage than it should be. And I have patients from Southeast Asia. They're from India or some other countries. They look thin. They're maybe 1 pound overweight. They might even have a normal BMI, but they're internally overfat and horribly diabetic. I have patients who gained just 5 pounds of abdominal fat. They're horribly diabetic. They lose it. They're non-diabetic. and they look skinny, sort of skinny fat the whole time. Like you can barely even tell. So, yes, if you have genetically low subcutaneous body fat, it's really tough to know. I also have patients who have a lot of subcutaneous body fat and they look kind of fluffy all the time, but their triglycerides are very low, their A1C is low, their fasting glucose is low, everything's fine. And they just have more insulation because, their ancestors have been living in Northeast Asia for the past, 50,000 years. And so they just store more subcutaneous fat. So there's these major genetic factors, and you could actually be fairly sensitive at way higher body fat percentages or super diabetic at way lower body fat percentages. It's just like BMI. BMI doesn't tell you what percent is muscle and what percent is fat. So on a population basis, it's helpful, but on the individual basis, it's crap because your bodybuilder is going to be obese on BMI and they have no body fat. Same thing with appearance. It's a little bit deceiving. A better option is to measure your waist to height ratio. You measure your waist circumference right at the belly button, basically abdomen fully relaxed, standing up. You measure your waist circumference right at the belly button. That should be less than half your height. If it's over that, you're probably in trouble. No matter what your weight is, no matter what your BMI is. And so this is one good thing to measure. I also really like fasting triglycerides. You don't want to be over 100. Fasting triglycerides over 100, you're probably somewhat insulin resistant. You're somewhat running out of storage room. Lower is better. So those are two really good ways to know how you're doing internally.
Good point mentioning the fact that it goes both ways, that somebody could look overweight and actually be metabolically healthy as well. Ted, I know you got to go, but we'll end on this. Somebody that has tuned into this point, they're excited about protein. They're going to start upping their protein intake through, skinless chicken breasts, whey protein shakes. They're really going to give this a go. Acutely or chronically, can we have too much protein? For somebody that's getting over ambitious and they really jack that up, is that ever a concern?
Well, so you're really not going to damage yourself. Basically, if we just gave you a plate of like 50 skinless chicken breasts and said, okay, I want you to eat all of these, try to harm yourself by overeating protein, you pretty much can't do it. The satiety is so high, you're just going to stop eating it. The only problem I see is that some people who just go way too crazy will overdo it and they're hungry all the time because they didn't eat enough calories. And then they're like, oh, this diet sucks. And then they just basically go back to eating donuts. So like anything else, you want to progressively overload it. It's just like exercise, where if you never exercise and I'm like, okay, you have to run a marathon and you just destroy yourself and you feel horrible and then you just don't exercise for months. It would be better to progressively overload that. You want to do the same thing with protein percent. You want to just increase it slightly, a little bit at a time in a progressive and sustainable fashion. So you don't just like try to eat 100% protein, be starving all the time, and then just rage quit. And you know what I'm saying? So you really don't want to go crazy with any of these things. You want to slowly progress them in a progressive fashion with like a progressive overload.
All right, Ted, really appreciate this conversation. This was great. We're going to link up your book, your website, your social media, everything in the show notes. Thank you.
Oh, yeah, absolutely. Thank you.
Now that you're done, you're going to want to stick around here and catch this other incredible episode. You don't want to miss it. I'll see you over there.
There are no essential carbohydrates whatsoever. None. Zilch, zippo. Telling people to have at least 55% of their diet in the form of the one macronutrient that we don't even need is the starting point that's wrong. You think